Yes, dear students, we are going through the chapter of rotational motion. Actually, due to this coronavirus, many topics have been deleted from syllabus. But I have seen that question in competitive exam are always there. So please don't get confused. Some topics are so fundamental that you can't ignore and you can't delete. For example, I am telling you one thing here. You will learn a wave chapter. Basically, the wave transfer energy from one place to another, and amount of energy transferred per in time through unit cross area is the intensity. But that definition is not meant in syllabus. And you might be doing question here, solar energy and other energy, and always we talk about the intensity of light, intensity of sound, intensity of electric field. So please learn these things. These are fundamental things. Some may say that this is beyond syllabus. Okay, maybe beyond syllabus, but something is to learn. But this is not beyond syllabus. Torque, concept of torque. Actually, when we were students, we were taught in other way, and when competitive exam came to us, we find unable to attempt the question. So please don't get confused or don't come in the persuasion of anyone that this is not our syllabus part. Yes, it is part of syllabus. To tell our name is syllabus. So in figure, I want here concept of torque. Actually, force produces linear acceleration. To produce force, we need linear acceleration. And we have learned angular velocity, angular motion, rotatory motion. In rotatory motion, I explained that there is, when angular velocity changes, there is angular acceleration. So to produce angular acceleration, we need torque. Torque is also called as torque. Torque, moment of force. Moment of force. But name does not help us to understand what is this. There is no simple definition of torque. There is no single definition of torque. Actually, turning effect of force to change the rotatory motion. What we require, that is moment of force. It is turning effect of force. A force. Actually, whenever you want to rotate a thing, you apply two forces. Spanner you use, then one side you hit, another side it is fixed with the bolt. Like the door, you open the door, your door is fixed with the hinge, and now you hold the handle and apply force. So two forces act automatically, and rotatory motion is produced. Not motion, rotatory acceleration is produced. Here in this figure, a body is at point P whose position is determined by Cartesian coordinate xy. Here R and theta are called polar coordinates. By position vector can be explained in terms of Cartesian coordinate as well as polar coordinates. Now, by applying this force acting on this, and the body is forced to move in xy plane only on a circular path. So radius OP equal to OQ. But R and R dash are the position vector which have different directions. That's why they are different. But basically R dash modulus r dash equal to modulus r equal to r, radius he have. And under the effect of this force, body goes from P to Q. Now using concept of work done, we will derive the expression for torque. So in figure, you can write here in figure a body under the action of force is forced to move, or there is word constrained to move. Constrained to move in xy plane. In xy plane. थोड़ा टाइम लगेगा समझने में. We will take some time and finally we will enjoy what we have learned. So now here vector f may have two component fx plus fy, yani along x-axis and along y-axis. Here it is a component, you can do this. Or we can write that vector f equal to fx I cap plus fy j cap. Now body goes from P to Q. Coordinates of point P are x, y, that of Q are x plus delta x and y plus delta y. So change in position vector. Actually delta r vector is equal to vector r dash minus r है. By this r plus delta r is equal to r dash, and vector r dash is equal to x plus delta x I cap plus y plus delta y j cap. It is the position vector r dash. Don't confuse, na? I have told you many times, if x, y are the coordinates of a point, then position vector is written x, y plus y j cap. And vector r equal to x I cap plus y j cap. Now, by solving this, you can get x I cap minus x I cap, y I cap, j cap. So we will get only delta x I cap plus delta y. It is the displacement vector when body goes from P to point Q. Now, by definition of work done, you know, work done in carrying the body from P to Q by this force F, that delta, na? Work done in moving the body from P to Q is given by delta W equal to vector F dot vector delta X. Remember, work done is the dot product of force and displacement, or here it is equal to Fx I cap plus Fy j cap dot delta x can, or delta r, sorry, delta r. This is delta r, sorry. Here is delta r. So it is delta x I cap plus delta y j cap. Now dot product I dot I1, I dot j0, j dot I0, j dot j1. So we get only here fx delta x plus fy delta y. This is the value of work done in terms of component of force and component of displacement vector. Now we want to find out value of delta x, delta y in terms of r and theta. So please don't afraid of the topic. You will enjoy later. There is triangle QOM. in triangle, yes, in triangle QOM, cos theta plus delta theta, base upon hypotenuse, OM upon OQ. Please retain in brain this equation 1. Now cos A plus B are told many times. Cos theta, cos delta theta minus sin theta and sin delta theta. Cos A plus B. Should I remind? Cos A plus minus B अगर है तो it is cos A cos B minus plus sin A sin B. ये by from trigonometry. So it is equal to this OM. OM is in fact to reach point Q we move this distance, so it is x plus delta x. X plus delta x OQ modulus R dash, modulus R dash is equal to x plus delta x upon R dash. Delta theta. Now, if delta theta tends to 0, means theta, delta theta is small angle, then cos delta theta is equal to 1 and sin delta theta is equal to delta theta. I have explained this thing in one video. जनरल मैथमेटिक्स यूज इन फिजिक्स के नाम से मैंने प्रूव किया हुआ है इसको, एंड मैनी पीपल हैव व्यूड दैट मैक्सिमम नंबर ऑफ द वीडियो फिजिक्स सीन मैक्सिमम बाय मैक्सिमम पीपल. नाउ cos theta here it is theta, cos theta based upon hypotenuse in triangle PNO, it is Pn equal to x. So from figure cos theta x upon r, ये 1 हो गया, माइनस sin theta y upon r in triangle this cos theta y, this is y, this is x, और sin delta theta is equal to x upon r है, sorry, x upon r plus delta x upon r. This x upon r cancel, तो minus y upon r delta theta equal to delta x upon r cancel. So we get here what? कि delta x equal to minus y delta theta. हमारी इक्वेशन 1 थी डेल्टा w इक्वल टू एफ एक्स डेल्टा एक्स प्लस एफ वाई डेल्टा वाई. नाउ अगेन इन ट्राइंगल, यूजिंग ट्राइंगल अगेन इन ट्राइंगल ओ क्यू ओ एम, sin theta plus delta theta equal to mq upon r dash, and again sin a plus b, sin theta cos delta theta plus cos theta sin delta theta equal to mq. mq means y plus delta y upon r. Again delta theta tending to 0, so sin theta here y upon r into 1 plus x upon r into delta theta, y upon r plus delta y upon r. Y upon r cancel, so we get here delta y is equal to x delta theta. Now we are going very close to the topic. So putting the value of delta x and delta y in equation 1, putting the value of x and delta y in equation 1, we get delta w is equal to fx minus y delta theta plus fy, it will be x delta theta. What is delta theta? Is the angular displacement. Delta r is the linear displacement. So it is equal to x fy minus y fx delta theta, delta w. Work done equal to this thing into angular displacement, or we can write that delta w is equal to tau into delta theta, where tau is equal to x fy minus y fx, and tau is called torque produced by force F. Force F about point of rotation O. यानी कि we get work done equal to torque into angular displacement. Torque into angular displacement. Work done by force into linear displacement. It is torque into angular displacement. Unit of work done same, joule. Torque unit from here. You get unit of torque as unit of torque is Newton meter. People is also calling it as joule also. क्योंकि force work done भी force in distance है. But this Newton meter. So this is the torque. Now we have got torque in Cartesian component of position vector and force. And from this figure, now I want to draw another figure to make you something clear. X, Y. Here it is the position vector R, and this theta and force F at this way. Now I produce it back. O point we can draw perpendicular here. So my aim here something different. This is Fx component and this is Fy component. Line of action of Fx, line of action of Fy. This is X, this is Y. So from this equation, X into Fy, X into Fy. So torque may also be defined as, and here torque produced by a force about any axis of rotation has magnitude equal to magnitude of force multiplied by perpendicular distance of line of action of force. Please see this thing. Actually, if I talk about xfy, this is x, this is line of action, magnitude of force fy है, then this fy multiplied per distance. Now y fx, this is the line of action of fx, this is per distance y. So in general, torque may also be torque produced by a force about any axis rotation or point rotation has magnitude which is equal to product of magnitude of one force and this perpendicular distance. ठीक है भाई? Now why this